April 13th, 1970. A spacecraft drifts 200,000 miles from Earth. Astronaut Jack Swigert flips a switch. A routine procedure done 100 times before. A sudden bang slams through the hull. Warning lights flood the panel. Oxygen begins venting rapidly into the void of space. And three men realize they are now trapped in a dying machine that's hurtling toward the moon at over 24,000 miles per hour. This is the story of Apollo 13. The year is 1970. America has already planted boots on the moon twice. Apollo 11 made history. Apollo 12 proved it wasn't a fluke. Now, Apollo 13 is supposed to be routine. The crew is a mix of experience and fresh blood. Commander Jim Lovell is a veteran. He's already circled the moon on Apollo 8. At 42 years old, he has more hours in space than any astronaut alive. Fred Hayes is the lunar module pilot, a former test pilot with steady hands. And then there's Jack Swigert, the command module pilot who wasn't even supposed to be here. 3 days before launch, the original pilot, Ken Mattingly, got exposed to German measles. Doctors couldn't risk him falling sick in space. So Swigert, a backup crew member, got the call. He had 72 hours to prepare for a mission to the moon. The spacecraft itself is made of two parts. The command module, named Odyssey, is the cone-shaped capsule where the crew lives. Beneath it sits the service module, a cylinder packed with oxygen tanks, fuel cells, and the main engine. Docked to the front is the lunar module, named Aquarius. It's designed to land 2 astronauts on the moon and bring them back. But buried inside the service module is a problem no one knows about. Years earlier, during a ground test, oxygen tank number 2 was accidentally damaged. Wires inside the tank were exposed to temperatures over 1,000 degrees Fahrenheit. The insulation around those wires melted. It wasn't caught. It wasn't fixed. That tank is now a bomb waiting to explode. April 11th, 1970, Kennedy, Space Center, Florida. The Saturn V rocket stands 363 feet tall. At 2:13 in the afternoon, the engines ignite. A pillar of fire lifts the spacecraft off the pad. The crew is pressed into their seats as the rocket climbs. Within minutes, they're in orbit. A few hours later, the third stage fires again and sends them toward the moon at over 24,000 miles per hour. For the first 2 days, everything is perfect. The spacecraft performs flawlessly. At one point, a controller in Houston jokes that the flight is so smooth, they're bored. It's the last time anyone mentions boredom. 5 hours into the mission, the crew just finished a live TV broadcast. Commander Lovell signs off with a simple good night. 9 minutes later, Houston asks Swigert to flip a switch. It's a routine procedure called a cryo stir. The fans inside the oxygen tanks need to spin to get an accurate pressure reading. Swigert flips the switch. For a moment, nothing. Then, a sharp bang. The spacecraft shudders. Alarm lights flash across the instrument panel. The master caution blares. For a split second, Lovell thinks Hayes is playing a prank. He's done it before, triggering the cabin relief valve to startle the crew. But Hayes looks just as confused. This is real. Swigert's voice comes over the radio, calm, measured. Houston, we've had a problem.
Hey, Houston, we've had a problem here.
At first, no one understands what happened. The data makes no sense. One oxygen tank reads empty. The other is dropping fast. 2 of 3 fuel cells are failing. Without oxygen, those cells can't produce electricity. Without electricity, the command module dies. Lovell floats to a window. He sees something that makes his stomach drop. A thin cloud of gas is venting from the side of the spacecraft. Their oxygen is bleeding into space. This isn't a malfunction. This is a catastrophe. The crew has maybe 2 hours before the command module loses all power. They need a new plan. Fast. Mission control scrambles. Flight director Gene Kranz gathers his Team. He locks the doors. No one leaves until they have a plan. His voice cuts through the chaos. Let's work the problem, people. Let's not make things worse by guessing. The math is brutal. They are 200,000 miles from Earth. The service module is crippled. The command module can't sustain them. But the lunar module is still intact. Aquarius was built to land 2 astronauts on the moon for 2 days. Now, it needs to keep 3 men alive for 4 days. It was never designed for this. The crew powers down Odyssey. They shut off every system except what they need for re-entry later. The capsule goes dark, cold, silent. Then they climb through the tunnel into Aquarius, the lifeboat. Controllers in Houston start doing the impossible. They calculate new trajectories. They figure out how to stretch limited water and power. They develop procedures that normally take 3 months in 3 days. The plan is simple in theory. Use the moon's gravity to sling the spacecraft back toward Earth. Fire the lunar module's engine to speed up the return. Keep the crew alive long enough to reach home. Simple in theory. Brutal in execution. A day and a half into the lifeboat phase, a new alarm sounds. Carbon dioxide levels are rising. Every breath the astronauts take adds CO2 to the air. Normally, lithium hydroxide canisters scrub the gas from the atmosphere. But there's a problem. The lunar module uses round canisters. The command module uses square ones. The shapes don't match. The crew has plenty of spare filters from Odyssey, but they don't fit Aquarius. In Houston, engineers stare at a table covered with random objects, plastic bags, cardboard from a flight manual cover, duct tape, hoses from the spacesuits. These are the only materials available on the spacecraft. They have hours before the air becomes toxic. The team works frantically. They build a crude adapter. A square peg jammed into a round hole using tape and plastic. It looks like a kindergarten art project. They radio the instructions to the crew. Step by step, cut the plastic here, tape there, insert the hose, seal it tight. The astronauts assemble the device in about an hour. They call it the mailbox. It works. The CO2 levels drop. The crew can breathe. But they're still freezing. With most systems powered down, the spacecraft loses its main source of heat. The temperature inside drops to 38 degrees Fahrenheit. Condensation forms on the walls. Water droplets cling to every surface. The astronauts wear their lunar boots to keep their feet warm. Swigert wraps himself in extra coveralls. His feet got wet earlier while filling water bags. Now he can't stop shivering. Sleep is nearly impossible. The cold seeps into everything. When they manage to drift off, any small movement disturbs the thin layer of warm air around their bodies. They jolt awake again. Water is rationed to 6 ounces per person per day, 1/5 of normal intake. The crew becomes dehydrated. Lovell will lose 14 pounds by the time they return. Hayes develops a kidney infection. Day after day, they endure. To get home faster, the crew needs to fire the lunar module's descent engine. But there's a problem. Normally, astronauts align the spacecraft using stars. A computer locks on to a known star, and that gives them a reference point for navigation. But the explosion created a cloud of debris that follows the spacecraft, thousands of glittering fragments. Every one of them looks like a star. They can't tell which lights are real. So Houston comes up with a backup plan. Use the sun instead. Controllers calculate exactly where the sun should appear in the commander's window at a specific time. Lovell manually aligns the spacecraft until the sun sits perfectly in his crosshairs. Then they fire the engine. The burn lasts 4 minutes and 23 seconds. It's almost perfect, less than 1 foot per second off target. The spacecraft accelerates toward Earth. Now they wait. As Earth grows larger in the window, a new fear takes hold. The explosion might have damaged the heat shield. The command module's heat shield is the only thing protecting the crew during re-entry. The capsule will hit the atmosphere at over 24,000 miles per hour. Friction will create temperatures exceeding 5,000 degrees Fahrenheit. If the shield is cracked, if even a small piece is missing, the capsule will burn up in seconds. No one can inspect it. The shield is on the bottom of the command module. They can't see it. They can't test it. They just have to hope. April 17th, 1970. 4 days after the explosion. The crew jettisons the service module. As it drifts away, they finally see the damage. An entire panel is missing. The guts of the spacecraft are exposed. Wires, tanks, wreckage. Lovell stares out the window. There's one whole side of that spacecraft missing. Next, they separate from Aquarius. The lunar module that saved their lives floats away into the void. Now only Odyssey remains. The crew powers up the command module. The walls are covered in condensation. Controllers worried that water behind the instrument panels might cause short circuits. But the systems come online. Everything works. They strap in for re-entry. The capsule hits the atmosphere. Outside, a sheath of superheated plasma surrounds the spacecraft. The heat is so intense, it ionizes the air. Radio waves can't pass through. Communication goes dead. Houston calls out, "Odyssey, Houston standing by." Silence. The blackout is expected to last about 4 minutes, standard for an Apollo mission. 4 minutes pass. "Odyssey, Houston standing by." Nothing. 5 minutes. Controllers lean forward. The room goes quiet. 6 minutes. Something is wrong. The blackout has never lasted this long. Controllers run through the possibilities in their heads. A damaged heat shield. A cracked hatch. Parachutes frozen into blocks of ice. 1,000 ways to die, and no way to know which one found them. Across the world, 40 million people are watching live, waiting. The silence stretches. Then, a crackle. "Okay, Joe." It's Swigert's voice, calm, tired. The room erupts. Controllers leap from their seats. Some cry, some cheer. In homes and offices around the globe, people exhale. 9 minutes later, 3 orange and white parachutes bloom against the blue Pacific sky. The capsule splashes down just 3.5 miles from the recovery ship, USS Iwo Jima. Helicopters race toward the floating capsule. The hatch opens. 3 gaunt, exhausted men climb out. They made it. The crew is flown to Hawaii. President Nixon awards them the Presidential Medal of Freedom. Mission Control receives the same award. Investigators later trace the explosion to oxygen tank number 2. The damaged wiring from years earlier sparked inside the pure oxygen environment. The tank ruptured, and a spacecraft built to reach the moon became a coffin hurtling through space. The lessons learned from Apollo 13 reshaped how NASA designed spacecraft. Redundant systems, better testing, new emergency procedures.